Hello friends, welcome to my YouTube channel of Debneel's Mathematics Desk. So it's class 9's video today and on a completely new chapter, statistics, stats and mathematics. Like you study the stats of various cricketers that runs wickets, so we will be doing statistics, okay? So it's a completely new chapter, so you will learn a lot of new concepts. So get ready for the awesome series on this chapter. So before beginning my video, a huge thanks to all of you who have been supporting my channel so well. Keep providing your support if you found my content, my videos very informative and helpful. Leave a like and share and subscribe my channel. It motivates me to make better videos for you all on these important and interesting chapters. So with that I begin this very new chapter for class 9. So as the name suggests, statistics is from stats. So here also you have two types, means one is the data, another is you can see the stats of that data. Suppose you have the names of five cricketers and how much runs they scored in 2023. Okay, that's also a type of stats of those players. That's how statistics is actually done, where in one means row or column you write down the names of your data, and in the other row you means write the means how much that data has been used, what is the quantity of that data. Also it can be told what is the frequency of the data. Frequency is the number of times a single data value has been used. So we will be understanding what is frequency, what is data, what is frequency distribution table, and class interval. So many things we are going to learn today. So today is actually a basics to statistics, you can say. So coming to the first part, I am giving you two things. One is, what can I say? Um, the temperature. One is there. Another one I am telling you, number of eyes in two people. Suppose these two are two sets of data. One is the temperature, suppose in what do I say? Europe, consider Europe, and the number of years in the number of eyes in two people. Okay, so you tell me, is the temperature means constant? No. So what is that? A temperature in any state or any place, it keeps on changing, right? Average temperature means over the years, over the months, temperature changes by drastic means actually. Okay, temperature is not constant, it's continuously changing, right? Like because of the global warming our temperature is now rising, average temperature of the earth. So the temperature is not constant, it is a continuous means type of data, you can say. Absolutely, a type of data which keeps continuously changing and which can't be means, what do I say, it's directly counted. Okay, see, a continuous data you can't means at one moment count and say what is it. So it continuously either keeps decreasing or increasing or does both at some means level. Like the population of India in 2011, it is suppose approximately something, what do I say, 4.6 million, and then 2012 3.9 million, and then 2013 7.2 million. Can means increase decrease, it is a continuous data, which means doesn't have a definite value, can't be definitely counted. So that is called continuous data. A set of data which can't be counted directly and means expresses a range of values is called continuous data. So by range, what I mean to say, suppose in the year of 2000 from 11 to 2019, if you are asked to find what are the temperatures in Alaska, then for 9 years there can be 9 different temperatures. The range is what? the lowest to the largest temperature. That's a range. It can't be means counted as a single value. There are many values and it has a range. Okay, like in my class means the roll numbers range. Okay, so it's 1 to 40, it's a range, right? So any value or data value that is in a range that can't be counted as a single value, that is called a continuous data. Remember this. But suppose this one, number of eyes in two peoples. Here you can, no man can have means different eyes, right? Unless anyone smashed him or her in the eye and just, what do I say, fighting. No fighting in maths. We will consider normal people like me, like you, and everyone. So number of eyes in two people, 2 into 2, 4. You can means here directly say how many eyes are there. Means directly you can count and tell the values. There is no range. It's a discrete and a separate single number. And the word discrete, absolutely. A data value that can be means represented in one single means value. It is called a discrete data. So what do we learn till now? Continuous data means data means given in some range or that can't be counted. It is countable but can't be counted at that single moment. It has a large range. That is a continuous data. But number of eyes in two people like this or number of students in your class, it is a fixed value. You can just count it and tell it, right? So that value will not change. In your class, how many students are there in 1 year? That will not change. But if it is given to you the number of students in your class from class 1 2011 to 2019, there you see in it can happen in 2011 you had 35 students, then few students means went out of the school, you had 33, then again few took admission, again the class strength increased. Like this a range of values can be formed. That is continuous. But if I means tell you the number of students in your class in 2011, in 1 year in only one class you can just count and tell how many students are there. It's a definite number. Okay, it doesn't change. So that's called a discrete data, a separate single and accurate data. It's a discrete data. Continuous means a range of values. Just remember this. This was about continuous data and discrete data. So let us do a few sums on this as well. So I will be writing four data given to me. We have to tell whether they are continuous data or discrete data. That's as simple as that. So see this number of children, because already I gave you the example. Number of children in your class. So see, here they're not mentioning in year, they're not mentioning a range of years. So here you can directly from the question say that, okay, you are asking me how many children are there, students are there in a class. I am just going to school and finding out. So you go to school, you check how many are there, and just that's a different unit. At that moment you calculate it, it doesn't change. It has no range. It is a separate means number of students. So as this value doesn't change and it is not a range, it is a separate number, accurate value. It is called a discrete data. This is discrete, okay? Now coming to the second one, sizes of shoes. So here see, sizes of shoes are separate numbers. Suppose if I tell I want to buy a school shoes. Okay, I check my legs foot size. Okay, and then I take the shoe. It has a separate number, right? According to my means foot, my shoe is means given to me. So that size of shoe is a separate number. It has no range. So obviously it is a discrete data. Now coming to the third one, this is basics. Okay, you have to means this is what like walking into the carpet of statistics. You can say means first of all you may slip on the carpet. That's why we are doing the warm up for you. Then you have to run on the carpet, do the hard sums, typical statistics. We will do that. Wait a little. In this video only we will do. Then time. Now see, time means keeps on going, right? time is at this moment, I am talking, I am writing, I am is doing something, the time is also moving. So it is continuously moving, so it is a continuous data. Easy. But if it was given to you, time at which you started doing homework today, it is a separate time at which you are starting the work. That is a separate means accurate single value. That will be discrete data. But here time means what? Time it keeps going on till infinity, it will keep going on, where we will not be on the earth someday, okay? So it's not going to end. It has a continuous means running. So that's a continuous data actually. Quite easy from the question you can say. Unless you have mentioned means particular time period, this time means the time that is just going and is was going, is going and will be going. Okay, next one. Distance traveled by a car. Huh. Think in a mathematical way. Can you means a car means suppose you told your brother you take you my car and go from what do I say, West Bengal to Mumbai at the airport, any house, for example. So at that moment, at that place, can you stand and tell how much distance your brother covered? You can't, right? You can't tell that what is the means distance he has covered. Means it can happen that he's taking various routes. Suppose he first of all went to the restaurant. He was feeling hungry. Okay, so that's why means he can means go anywhere. He can go to a shop to do shopping. He can means go to meet his any neighbor. Means it is not that he will directly travel to Mumbai airport. Old fashioned people, why? They can do many things and then go to Mumbai. So then the distance increases. If means suppose you have got an idea, I know from here till Mumbai airport my brother will cover of 760 kilometer. But your brother, I want to go to the restaurant, I want to buy clothes, I want to watch a movie, I want to go here, I want to go famous museums. By doing this, he's increasing his distance traveled, right? Till he reaches Mumbai airport. So there your assumption was not actually true. It got increased his distance. So that distance traveled by a car can't be told by us. What is the accurate distance traveled by a car? Okay, means it is a continuous data, it can change which distance you are considering that one will travel. If he or she travels means in different routes and reaches the goal, then it might take a more distance. Or he or she, suppose um, another example I'm giving you. I am my mother told me that go and bring sweets from the shop nearby. He or she knows that from here in straight to my the shop, sweet shop, one way is there, I'm going to go by that way only. So that has suppose 200-meter distance, but I am means I know about my place, I know a shortcut, I use that and I convert it in 40 meters. So my distance changes, it doesn't remain the same, it can't be accurate. Okay, you can means just tumble and go, means go this side, go that side, and then go. You always have to go straight, that doesn't mean, right? The distance can change for a particular location. So that is a continuous data, what I'm trying to mean. Means here many of you can make the mistake, that's why I took the time. Distance traveled by a car, well, it's a definite unit, it's a definite number. So I will write it as discrete unit. No, how can you tell that the distance traveled by car you are assuming is means true? He or she can take any other route, go somewhere else and then go to your goal. Distance will increase, or use a shortcut and go to the goal. Distance will decrease. Does it remain same? It continuously changes. So it's a continuous data. So you have to be very careful while answering these questions. You have to consider yourself at that moment, at that place. Sizes of shoes, you are at a shoe shop. According to your foot size, the shoe will be given which has a only one size. One size, single unit, discrete data. Number of children in your class, you go to the class, calculate your friends and tell how many students are there. Only one value, discrete data. Time, going till infinity, till we go to God and again we get born. Okay. continuous data. This has traveled by a car. Sorry guys, I'm coughing. I know because I'm not well. Yes, I was well for 5 to 6 days, but this cold is like my bad friend. You can tell. So continuously troubling me. Still, I'm trying. So distance traveled by a car. I already told you. This is all about discrete and continuous data. Continuous means a range of values. Discrete means a single accurate value. Okay. This was the first part. You got this, I hope. Now, I'm giving you a situation. Suppose you gave, so what do I tell? Any competitive exam. Suppose we in my school, I have means given the competitive exam of IOM, International Olympiad of Mathematics. I think the full form it was. I don't remember. Suppose IOM is the exam you gave. Okay, in this exam IOM, and you get three exams: IOM, IOS, International Olympiad of Science, and then whatever else. What can you have? Uh, International Olympiad of any other subject you have? Literature. Let it be any competitive exam you have. International Olympiad of Maths, International Olympiad of Science, International Olympiad of uh, what was that? Literature, right? I told you. Yes. Suppose the marks you got in these Olympiads is given in a table like this: IOM, IOS, IOL. In IOM you got suppose out of 196. In IOS you got 97. In IOL you got 95 out of 100. Okay. You will be telling, wow, beautiful data. I can directly see from the table that my data is given to me. But you are the means children of the advanced means era. So this type of easy, no meaning, so means old fashioned tables. Do they look nice? What if I means frame a table like this? A data column to write the exams you have gave. Okay. And then a tally column and a frequency column. Okay, so that's means for my convenience is decreasing the marks. Consider it out of 10. Okay, the exams, competitive exams are given out of 10. Doesn't happen, just consider. So here you have got 8 out of 10. Everyone tells that everyone gets less marks in maths. So I want to agree. Okay, want to be a common person. That here you got 7 out of 10. Here you got suppose 10 out of 10. Many like to read stories, so literature might be easy for them. So what if it is told to you, represent these marks in another form of a table? Now I have a very interesting method for you. I have a table which consists of a data column to write what exams you have given. For exams you have given IOM, you have given IOS, you have given IOL. I have a frequency column. Frequency means how much you have got in the data or what is the quantity of your respective data. Here IOM is your data. What is the quantity of IOM? 8. Quantity of a separate data is called frequency. So frequency of IOM is 8. Frequency of IOS is 7. Frequency of IOL is 10. I have got a tally bar as well. Most interesting one. The rules of writing tally is like this. So for numbers up to 4, tallies are this. Tally 1 equal to write 1 in tally numbers, you have to put one stick only. That not that candlestick. A stick in mathematics, a stick using your pen. Okay. For writing 2, you have to put 2 sticks. For writing 3, you have to put 3 sticks. For writing 4, you have to put 4 sticks. For writing 5. How can you write a number 5? You will tell 5 sticks? No, I don't agree. I think that this is the correct way. First of all, write 4 sticks. Then from the middle, draw another stick. This is how you write the number 5 in tally writing rules. Whenever you are means framing the data frequency table, you have to write the respective tallies for the frequencies. That's the rule. To write 5, we have to do like this. To write 6, what do you have to do? 6 is what? 5 plus what? So first of all, write 5 like this, and then another stick. See here, first of all 5, then one stick. Don't write 5 plus 1. This plus is not required. Okay. And 7 will be what? 5 plus 2. 1, 2, 3, 4, 5. 1, 2. 5 and another 2 sticks. 7. Means you can't do like this. Dot, dot, dot. I got confused. This is wrong. This is oh man. You can. This is right. Remember for 7. Okay. I'm just trying to explain you. Up till 5 the system is easy. 4 up till 4, 1, 2, 3, 4. 5, 1, 2, 3, 4. From the middle cut it down. 5. 5 sticks. 6. First of all write 5 plus 1. 1 stick. 7, 5. Then write 2 sticks. 7. 8. Write 5 plus 3 sticks. 9. Write 5 plus 4 sticks. 10. Write 5 2 times. And then 11 will be what? First of all write 5. 5. You have to write in units of 5. Means you can take up to 5 maximum. Suppose it is 29. Then 5 into 5 means 5 times you have to write 5. Then 4. 29. That's how you have to do it. Okay. Don't worry, the question maker is not that mad that he will want you to write the frequency of 90 using tally. Then he or she or me, no one in the world wants to make you all mad. Okay. This is the tally writing rules. Okay. Now then, let me just rub this. How was the example? Very nice, right? Now see how the table will be formed. So my frequency in IOM is 8. 8 is 5 plus 3. 1, 2, 3, 4, 5. 1, 2, 3, 8. 7 is 1, 2, 3, 4, 5. 6, 7. 10 is 2 times 5. This is called, for a given set of datas, the frequency distribution table. So, which one is looking more good? I think that means, see, if you do this table, no. Okay, I can understand your table. The teacher will have this type of depressing attitude. But if he or she sees that, wow, you have written using tally, it's looking quite nice, good design, good structure, I think you will get more marks. So follow this. This is called frequency distribution table. So basically the system is, for whatever data you are given, means anything it can be. The things that you are given, write those data in the data column. For each of the data, what is the amount of the data used? That is the frequency of the data, right beside it in the frequency column. In the middle, you have to write the tally for the respective frequency. And then accordingly frame your data values. But a huge but comes into the play. What is it? Suppose another case. This is clear to you. So then tell me this. Suppose, okay, means what do I say? Marks. Okay, let us means do the sum. From the sum we will understand. So I am doing the question 5. Okay, I am writing question 5. We did 4 means continuous discrete sums. Now question 5. So here what I have, I think 24 students gave an exam. So 24 students, suppose of your class, gave an exam. Okay. So their marks are given to me. Marks of 24 students. It is like 45, 48, 15, 23, 30. 35, 40, 11, and max marks is 50. Not for this sum. Students get the exam with a maximum marks 50. Okay. Then 29. Unfortunately, one got 0. Someone got 3. I think it was a maths exam. 12, 48, 50, 18, 30. Yes, some more are there to trouble you. You will understand what is it. 15, 30, 11, 42, 23, 2, 3, 44. Suppose these are the marks of the students and you have been told frame frequency distribution table. So the format of frequency distribution table is what? Here you have data, here you have, okay, another thing is there, using, I am going to explain class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Something is given to you. So first of all, you know the format of frequency distribution table, data, and then you have your, what does that? Tally frequency. This is the format. But data is what? The separate values used. So I told you the separate means data means your separate things. So here at the statistics that you are going to do, data is what you know. Here many data are there. Means any can be repeated without considering the repetition. What are the separate numbers used? Now you tell me. Will you write each of these numbers which are not repeated? Means whatever the number is repeated, write the number only once. Without repetition, will you write all the separate numbers one after the other in a data column and then see how many times that number has been used to write the frequency? Do you want to become mad? No. So this class interval that is being given to you on this right left hand bottom, it's a beautiful solution, okay, on this whiteboard. So class interval is the range, or means a range of values you can take. What you are doing, you are about to write all the separate numbers which have been used without repetition in the data column, and then for each number then check how many times the number has been used, frequency, tally, frame a table that will destroy my board and then go into page. I don't want to do that. I have another solution. So what you can do here is you don't have to means include the numbers, it's write the numbers separately. You have the ranges of the numbers. This is called a class interval in the form left hand means lower limit to upper limit. This left hand value on the side of the dash is called the lower limit, and the right hand side of the dash is called the upper limit of a class interval. Okay. So data. Our data will be these class intervals. Why? Because you are about to take the numbers separately. So this is also the range of the numbers. Let me write our given data 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Now you'll be telling, okay, I understood. What you understood, I know you did, but let me also explain. Here you have to check in each of the ranges how many numbers are there, and that is the frequency of this range. But while you are calculating the number of values in a class interval or range, you can take the lower class limit as a number from the given data, but you can't include this upper class limit. Only for your last class interval, you have to include both the lower class limit and the upper class limit. I'm telling you what is the system. First is the range 0 to 10. So Means you can't include, if the number 10 is there in this numbers, you can't include 10, you can't include the upper class limit of a number, means of a class interval. You have to make see from 0 to 9 among these numbers which are there in the given set of values. So then see, 0 is 1, obviously 3 is there, 2 is there, 3 is there. Repeated values will count here, okay. So see, then 4 values, these 4 numbers are there between 0 and 10, including 0 and up to 9, excluding 10. See, here was 10 there, was, are you there 10? Not there, easy. So then 10 is not there, so up till from 0 to 10, 4 numbers are there. So frequency of this range is 4. Then for 10 to 20, now you can't include the number 20, the upper class limit, if it is present here. So then from 10 to 19 you have to see. Now you can include 10. Now see, this 10 becomes a lower class limit of this class interval. So you can include that. So then 10 to 19. Where are you? This number can be 1. This is 1. This is another. This one is another one. Another. Wow, so many. So many people. So in the range of 10 to 20. How many numbers are there? 1, 2, 3, 4, 5, 6. 6 numbers. Okay. Range means frequency of the range 10 to 26. Means 6 values are there between 10 to 20. Then from 20 to 30. How many numbers are there? Now you can't include 30. 30 is the upper class limit. If it is present here, you can't include it. 23 can be possible. 30 can't be possible because 30 is the upper class limit. Then you have, what do I say, 30, 35, 40. So you have now 29. 29 is another value. Okay. Then you have, now again see, these numbers are not there, but again 30 is there, you can't include 30. 30 is the upper class limit. Again 30 is there, can't include you here. You are the upper class limit of a class interval. What to do? We can't include you while we are calculating the values in that range. 42 is not, for 23 is possible. So up till 9, till now, 23, 29, 23. Okay, these are the values. Are they only the values? Yes. So the number of means values between 20 to 30 excluding 30 is 3. So from 30 to 40. Now you can't include 40 if it is there among these values. So 30 can be included now. I'm putting a cross, okay. 35 can be, 40 can't be included, upper class limit, can't be done. These can't be done. 30 can be included. 30 again can be included. So these are the numbers between 30 to 40. So 1, 2, 3, 4. 4 numbers. So the number of values between 30 to 44, frequency of this range is 4. Now see, this is the last class interval of your data value column. Now you can include both the lower class limit and upper class limit if they are present here. Then see, 45 is one between them. 48 is one between them. 40 can be included lower class limit. 48 can again be included. 50 can be included upper class limit because last class. Then 42 can be included. 44 can be included. So how many numbers? 1, 2, 3, 4, 5, 6, 7 numbers in the range 40 to 50. This is the system of data frequency table from the huge set of values where you will be given ranges of values or class intervals which will be your data columns respectively. For each separate data column class interval from the starting till the second last class interval of your data column, you can't include the upper class limit of your data column in the set of values. At the last class interval of your data column, you have to include both the lower class limit and upper class limit. Now another beautiful information. What is your total frequency? 4, 6, 10, 3, 13, 4, 17, 7, 24. How many students give the exam? How many marks are there? 24. So your frequency is correct. Total frequency. Now tally to write 4, 4 sticks. 6 is 5 plus 1. 3 is 1, 2, 3, 4 is again 1, 2, 3, 4. 7 is 1, 2, 3, 4, 5 plus 2, 7. This is your frequency distribution table. So I hope you understand the basic concept now of frequency distribution table. What I'm going to do, I'm going to leave it up to here till for today because I want you to understand from this sum how what is the basic system. This is a very basic sum. Okay, just understand. You will be given the class intervals. Okay, then those are your data column values for each class interval. How many numbers are there in that range? That is your frequency. Except for every class interval, you can't include the upper limit. Except for the last class interval, you have to include the lower and upper limit as well. Okay. This is data frequency or frequency distribution table. And also remember what I told you before, the discrete and continuous data. That's all for today actually. Little things, but I hope you understand. So part 2 actually is going to be much more detailed because we are going to do the typical subs and concepts of statistics, frequency distribution table in that chapter, means video. So get ready for that. This was a brief introduction to the statistics for class 9. So then if you found this brief introduction of statistics and discrete and continuous data and frequency distribution table, system and format and formation was clear to you, leave a like and share and subscribe my channel. It motivates me to make better videos for all of my little friends on these interesting topics. So part 2 I told you before about a detailed discussion concepts of this beautiful table format, class interval, class mark and adjustment of class intervals, where here see the upper class limit of a class interval and the adjacent lower class limit is same. But what if they are not same? What can be the case? Adjustment factor will come into play. We'll learn about that in the next video. Stay tuned till that. Have a good day. Take care and goodbye. Thank you.